So now even is very similar to SN1 what we have learned in the previous lectures. So SN1 mechanism used to go through a carbocation formation, removal of an existing leaving group, formation of a carbocation, rearranging itself, and then a nucleophile used to attack and then the molecule used to form. The very similar mechanism will be followed by even also. There are few things which we have to remember for even. First is we need a weak base for even reaction to take place. Weak base like alcohol. We will not take water as a weak base because water is not capable of doing the elimination reactions. Though it is a weak nucleophile, it is not a good base which can do the elimination reaction. Second is we need temperature. This we have already discussed when we were doing the introduction of elimination reaction. We need little amount of heat. Okay. Now let's take an example. I have a molecule like this. Okay. So now, as I had discussed in the introduction of even, how the steps of even takes place. First of all, removal of X takes place and then the removal of hydrogen takes place. I can write this CH3 as CH2H. Okay. Now, or to just simplify the question a little bit, rather than taking R, let's take it CH3. Okay. So, this is my alpha carbon and this is my beta carbon and this is also my beta carbon. Now in the presence of alcohol, what will happen? First of all, removal of X will take place. X will get removed and a carbocation will be formed. So intermediate state will, in intermediate state, we will get a carbocation formation which can rearrange if required. So this is the carbocation intermediate. Carbocation intermediate. Rearrangement is possible. Okay. Now, my ROH will act as a base and will try to remove the hydrogen which is present on the beta position. So I have two beta positions. This is acting as a beta position and this is also acting as a beta position. Now this molecule is symmetric, so it doesn't matter from where the hydrogen is getting removed. So let's assume that this oxygen has attacked on this beta hydrogen to remove it. So hence what will happen? The structure or the reaction will look like this. This oxygen will try to remove this hydrogen. Hence, removal of H plus will take place and an alkene will be formed. Okay. Now we have to just look at two things. So there are two possible structures or there are two possible products which can form. One, I have opted for removal of hydrogen because this species is acting as a base. And hence it has abstracted the hydrogen from beta position and the alkene has formed. Now if let's say it would be and this reaction, as I told you, will take place in the presence of heat. So to act this species as a base, we need heat, and then this removal of hydrogen will take place and alkene will be formed. Now at room temperature, what will happen? This ROH will act as a nucleophile, and rather than removal of hydrogen, what will it do? It will try to attack on the carbon where the positive charge is. So it will attack on the carbon, act as a nucleophile, will get attached over there rather than removal of hydrogen. So substitution will happen exactly the way how in SN1 used to happen. So one pathway will go through E1 and other step will go through SN1. So how the reaction will take place? Let's see. CH3, CH2, CH2H and plus. So my OH or my oxygen will attack here, forming CH3, CH2, OH2 plus CH3, which will, this is a protonated alcohol. This alcohol will lose one of its hydrogens so that this positive charge can be balanced out, or oxygen can gain its pair of electron to remove this positive charge. So removal of hydrogen, and the compound will become CH3, CH2, OH, CH3. So this is my SN1 product and this is my even product. So whenever elimination reaction will take place, there are some substitution products will also form and elimination products will also form. So in this case, what we have seen, the reaction can go through two pathways, and in fact it will take place through two pathways, because some of the molecules will act, some of the molecules of your ROH will act as a nucleophile, and rather doing substitution, rather doing elimination, they will go through substitution, and some of them will act as a base and will do elimination. So whenever elimination reaction is taking place, we will get SN1 product also and we will get even product also. Now, as in the case of SN1, we had seen that the initial reaction when the carbocation is forming, that is an RDS. So removal of X was an RDX in SN1. Similar way here also removal of X is an RDS. So this is a rate determining step, this is a slow step. Whereas rearrangement and then attacking as a base or a nucleophile is a fast step process. So kinetics of this reaction will also remain same as the kinetics of SN1. So let's write down few important key points of this reaction. First key point. In first slow step, leaving group will leave, forming a carbocation. In first slow step, leaving group will leave, forming an intermediate carbocation. Second point, intermediate carbocation can rearrange to get better stability. In second fast step, base will attack on beta hydrogen. And will abstract it forming an alkene. In the last point, write down, in this reaction SN1 will take place in parallel to E1, and hence we will get SN1 and E1 both products. Let's write down the information about kinetics of this reaction. Kinetics, rate of this reaction will be directly proportional to the concentration of the reagent. Very similar to SN1, it will not depend upon the base concentration. Why? Because base is coming into the picture in the fast step. In slow step, only Rx is present. So rate is directly proportional to the Rx. Order of the reaction 1, and molecularity of the reaction is also 1. This is about our even reaction. Now we'll talk about different other cases in even, where this I had taken an example where we had a symmetric chain. Now we'll be taking an example where we have a non-symmetrical chain, and how we will decide which hydrogen to remove when even reaction is taking place. Now we have seen the mechanism of even, and what we have noticed is whenever even is possible, our SN1 products formation is also possible. So when we get a question, how will we decide whether the reaction will go through even or SN1? Actually, whenever the reaction takes place in the normal condition, both the reactions can happen even as well as SN1. See, look at the scenario when a when a nucleophile or a base is attacking on the carbocation. So when you have a species which is acting as a nucleophile or a base, we have two situations. One is it will act as a nucleophile, it will attack on the positively charged carbon, and it will form a bond, and it will form an SN1 product. Whereas in the case of base, it will abstract the beta hydrogen and will form an alkene. Which one is more favorable? Just think on yourself. When you have a negatively charged species or electron-rich species, it will be attracted to a proper positive charge more rather than getting attracted towards a partial positive charge. And hence, the chances of doing SN1 reaction will increase automatically. So definitely, this kind of scenario will favor the SN1 type of scenarios more. Why? Because this electron-rich species will get attracted towards the positive charge, which is a proper positive charge over there, and will form a product. So SN1, in general situation, SN1 favors over even. Now, so what is the determining factor, or which factor will give you the even more, or how we can get even product more in our system? So let's see what is the dependent factor. That is temperature. As I have mentioned when I was talking about elimination, that we require heat for elimination reaction to happen. Now let me show you a graph, product versus temperature, where we can understand how according to temperature the SN1 and even products will vary. So this is my graph. This is temperature, and this is products. This is 100% of product. This is 80%, and this is 20%. So when we talk about SN1 is favored by low temperatures. Substitution in general is favored by low temperatures, and elimination is favored by high temperatures. So when the temperature will increase, automatically substitution products, the percentage of substitution products will decrease, whereas the percentage of elimination products will increase. So let's see. This is my SN1 product initially at room temperature or at a lower temperature, and as the temperature will increase, the percentage of SN1 product will decrease. This is SN1. This is my SN1. Whereas for even, as the temperature will increase, the percentage of the product will increase. Now what we can see over here is that at certain point both the percentages are exactly same, that is 50%, and what will be this temperature approximately? This will be somewhere around 50 to 60 degree, where we will get 50% of SN1 and 50% of even. Now higher the temperature, more will be the percentage for even, and lesser the temperature, more will be the percentage for SN1. So this is my even. Okay, so when we see the questions, that will be quite at that time it will be quite evident which reaction is going towards SN1 and which reaction is going through SN2. Sorry, E1, because the temperature will be provided, and it will help us in understanding whether the reaction is going through SN1 or E1. And the other factor which can decide whether the reaction will go through SN1 or E1 is whether the attacking species will act as a base more or will attack as a nucleophile more, and that we will get to know when we'll see the questions. We will understand at that time that whether we have already discussed this in base versus basicity versus nucleophilicity, that a species can act as a more like a base or more like a nucleophile. You'll get more practice when we'll do questions, and you'll understand better at that time.